Hi, we're on the second video for section 4.3 and whoops, I didn't erase a couple of places there, and we're going to look at these two equations. Now, on these types of equations, I can't just multiply one equation. I'm going to have to multiply both. I'm trying to get opposites, so I either want to have a negative 24x, and no, I can even do that. I could do a negative 12x, and I could do a positive 12x, right? So if I multiplied the first equation by negative 2 and the second equation by 3, this is what would happen. And so let's just do that. So let's take this first equation, and I'm going to multiply by negative 2. And on the second equation, I'm going to multiply by 3. Now, you have to multiply every single term. Sometimes students forget the term on the right-hand side of the equation. So let's rewrite. So I have negative 12x plus 10y equals negative 14. And then on the second equation, I have 12x minus 18y equals 21. And then I add these equations together. Now I just have to get either the x's or the y's to be opposites, and this time I got the x's to be opposites, which makes negative 12x plus 12x is 0. And then I go to the 10y and the negative 18y, and that's negative 8y equals 7, right? So we're just going to divide by negative 8, and y equals negative 7/8. All right, so that's going to be in my ordered pair like this. And then I just pick one of the equations, and it does not really matter. So let's take the second one, 4x minus 6y equals 7. I'm going to replace y with negative 7/8. And then that's the equation that I'm going to have to solve for x so that I can find that. You notice that these are a little bit messy here. Okay, so I have 4x, let's see, that would be, I could simplify, 2 into the 6 is 3, and 2 into the 8 is 4, so that's going to be plus 21/4 equals 7. I'm going to subtract the 21/4 from both sides. So 4x equals, let's see, that would be 28 over 4 if I got a common denominator. So 28 minus 21 is 7. And then I'm going to multiply by the reciprocal, or you're dividing. You can look at it either way. And x is 7/16. Okay. So that's kind of a messy ordered pair, but that's okay. It works out this way sometimes. All right, next. So let's take a look at this equation. On this one, I could just multiply one equation. So I'm going to multiply the first equation times negative 2. Let's see, let's just do this times negative 2 like this. All right, so when I rewrite that, I get 4x. Hold on, that's a negative 2. You can't see my negative very well. Let me make that bigger. Negative 4x minus 2y equals negative 12. And then I'm going to write the 4x plus 2y equals 12 below that. And you guys, here's what happens. I get zeros for the x's, zeros for the y. I even get zeros for the 12s. Right, because one's negative and one's positive. So this is 0 equals 0. Actually, these two lines are parallel lines. So if I had solved them each for y, they would have the same slope but a different y-intercept. When this happens, we call this an infinite number of solutions. Solutions, infinite number of solutions. So it doesn't just have wait a minute, this is not parallel. I said it was parallel. No, it's not parallel. These are the same equations. So if I solve them, because parallel lines have no solution. Sorry, you guys. Anyway, these two equations are exactly the same equation. And that means an infinite number of solutions because it is a line, right? The same line, both of those. Okay, so I threw in these that are kind of messy ones because I want you to be able to deal with them when you find, when you see one of these. So the first thing we're going to do is just get rid of fractions. On the first equation, we can get rid of fractions by multiplying by 4. And we rewrite this. So that's 8x minus 3y equals negative 12. And then on the second equation, we're going to multiply everything by 9. Remember, you can always use your fraction calculators for this too. And rewrite that. So that's 9x plus y equals, 3 goes into that, 39. Right? So when we simplify that, we multiplied through by 9 to get rid of the fractions. And that's what we end up with. So if we multiply the second equation by 3, okay, so I'm going to have to rewrite these again. 8x minus 3y. Hold on, let me just write it over here. So 8x minus 3y equals negative 12. When I multiply the second equation by 3, then I get 27x plus 3y equals 39 times 3 turns out to be 117. All right, I didn't know that just off the top of my head. All right, so we add these two equations together. Remember, it's the addition method, and by using it, we eliminate one of our terms. So that's going to be 35x equals 105. And divide both sides by 35. And we find that x is equal to 3. Okay, now I don't really like going back to the original equation, so I'm going to go back to the first equation after we cleared the fractions, and I'm going to substitute for x. Right, I'm going to substitute negative 3 or positive 3 in for x. So 8 times 3 minus 3y equals negative 12. And then I'm going to go ahead and multiply that out. So subtract 24 on both sides. And that's negative 36. Divide by negative 3. And we end up with a y that equals 12. All right. So my solution to this system is 312. Remember, if you were graphing, these two would intersect at 312. Wouldn't be the greatest one to have to graph, though. Okay, one more question on this lesson and we're finished with that. I do have to clear the fractions on these two equations. So for the first equation, I'm going to multiply by 4 on both sides. Okay, so here's what happens. 2 goes into 4 2 times. So I'm going to have 2 times x plus 5 equals y plus 14. All right, so now we always want to get these rewritten in standard form. So I have to do a little work with this. All right, so I'm going to subtract the y, so that's 2x minus y. I'm going to subtract the 10. All right, and so I just wanted to get the y on the other side, and that's equal to 2x minus y equals 4. All right, so that's what that looks like once we have it all simplified into standard form. Multiply this second equation, both sides, times, whoops, not by 3, by 6. I was about to say 6, and notice I wrote a 3. Okay, so on this one, all right, 3 goes into 6 2 times, so I have 2x equals, these 6's are just eliminated, right? They equal 1, equals 2y plus 2. All right, so if I subtract the 2y, I have 2x minus 2y equals 2. Okay, so notice on the top, the first equation, I have just a negative 1x. I'm going to multiply that one times negative 2, because I need it to be positive, because in the other equation I have a negative 2y. So by negative 2, and then that's going to be negative 4x plus 2y equals negative 8. I'm going to add those together. Okay, so negative 2x, the negative 2y plus 2y, those are eliminated. And I have negative 2x equals negative 6. Divide by negative 2 on both sides, and I find that x equals 3. All right. So I'm going to go back to my equation, this one, right? And I'm going to substitute in a 3. So 2 times 3 minus 2y equals 2. Subtract 6 on both sides. Negative 2y equals negative 4. I divide by negative 2 on both sides, and I find that y equals 2. So the solution to the system is going to be at 3. Oh, I just keep doing that. 3, 2. Let me make a better parenthesis that covers the whole thing. Alrighty. And then there's just one more thing. This is just explaining what we've done. Step 1, rewrite the equations in standard form if you need to. If necessary, multiply one or both equations by a non-zero number so that the coefficients of a chosen variable in the system are opposites. I've been talking about opposites as we've gone through this. Add the equations, and so on. So I won't go through that whole thing, but maybe that'll help you when you are working on this. And that's the end of section 4.3.